Here's our video on solving inequalities by multiplying and dividing. And we already have solved inequalities by adding and subtraction. So let's just review that before we continue. So here we have a negative 4 plus v and is greater or equal to 12. Maybe we should have made that something different. Let's say w, it looks better. So again, we have a negative 4. We want to do the opposite. So we'll plus the 4 on both sides. Plus 4 on both sides. Now we have w is greater or equal to 16. Remember, we're plussing on both sides. So that is our inequality statement, and we can draw a line. Put that 0 there, and we can say that's 16. Now we're saying it's greater or equal, so we can circle in. And so w is going to be greater or equal, so the line goes that way. Okay, so that's with division. That's with addition. It's the same with subtraction. And let's just look at something here. This is called the division property of inequality. It's a statement you need to know. When we're doing negatives, and we'll do a lot of negatives, you have to remember that you have to, if you divide a negative, let me just make an equation here. Let's say we're going to make a negative 5 q is greater than 10. Just do something like that. So we know that anytime there's a number, which we call the coefficient, next to a variable, it's multiplication. So anytime you divide a negative number on both sides of the inequality, you've got to flip the sign. So this is a negative number. I'm going to divide the negative 5 on both sides. This is just like we would have done with linear equations. Same concept. Now you see I'm dividing a negative on this side and that side, so those are both sides. So if you do that, if you come across that, then you flip, you reverse the symbol. Instead of being greater now, it's going to be less. And it's going to be less than negative 2. So remember that when we're doing division with negative numbers. So again, if you want to write it down, I'll put it up here. If you divide each side of the inequality by the same negative number, which we did here, the inequality symbol is reversed or flipped. So if you want to pause the tape and write that down, do that. So again, there was a negative number on this side. We divided it because this is multiplication. We want to do the opposite operation. We did it on both sides, and q now has to be less than negative 2. If you want to check, something that's less than negative 2 would be negative 3. So if you say negative 5 times negative 3, that'll be negative 15. And a negative times a negative is a positive. That'll be 15, and 15 is greater than 10. When you check, you go back to the original symbol. Q has to be less than negative 2. Let's do another example of that. If I had a negative 6m is less than, let's say, 18, how would you do that? Okay, so again, we're going to divide the negative 6 on both sides. And since we're dividing a negative on both sides, we've reversed the symbol. Right? So now it has to be, m has to be greater than negative 3. So go back to the original inequality, this one. Plug in any number that is greater than negative 3 into this equation, and you'll get the proper answer. So if we said negative 6 times negative 2, negative 6 times negative 2 is 12, and 12 is less than 18, so it works. Let's try it again. What else is greater than negative 3? Let's erase that. So 0 is greater than negative 3, right? So if I say negative 6 times 0, will it be less than 18? 0 is less than 18. It works. And you can do it with 100. Negative 6 times 100. 100 is bigger than negative 3. So negative 6 times 100 is negative 600. And negative 600 is less than 18. So it checks out. See if you can do this one then. What if I had 5m is less than or greater than negative 10? Try that one. Okay, now here I was trying to trick you. When you divide the 5 out, it's not negative. So you're only dividing a negative on one side. And you're not, so you're not flipping the signs. It's going to remain that way. So m is going to be greater or equal to -2. You don't flip the sign because the 5 was positive. So I was trying to trick you. Now you can do this with division also. So let's try one with division. Right, here we have x over 4 is greater or equal to 11. So in this case, we want to either multiply up or divide down. That's a shortcut. If we divide down, we don't have a number to divide down. Think of D for divide, down. But we can multiply up. So remember that rule we talked about. So now 4 times 11, so we can bring that x is greater or equal to 44. Our answer is solved already. And we can graph it. Put 44 there. Circle it in because x, it says it could be equal to 44 or greater, and there's our line. Okay, let me give you one. Let's see if you can do this one by yourself. You should pause the tape. Let's say I had g over -8 is less than 2. Now before we do this, I want to show you something. What you're actually seeing here, and again, you can multiply up, but what you're actually seeing is you're seeing -1/8 g is less than 2. That's what you're actually seeing here. So keep that in mind. And you can perform the division operation. So you have 1/8 g. So what you want to do, and I'll write this over again. So you're having -1/8 g is less than 2. So you want to divide out the -1/8 on both sides. It cancels. So do the rest, pause the tape, and see what answer you get. Okay, again, so you're going to divide -1/8 on this side. Bring down the g over here. And remember, you're dividing on both sides. So you got to reverse the equation. So what you see here then is you're going to get a -16. And how I got that, I'll just show you. Let's write this. It's over here. So you're saying 2 divided by -1/8. So it's 2 over 1 divided by -1/8. And remember, with division, you flip. So it's 2 over 1 times -8. So that gives you -16 over 1, which is -16. So remember, we flipped it because we divided a negative on both sides. Okay, what if we had something like this? This is a little different. Here we have the variable as negative. So we can just multiply up. We're saying -g is less than 16. That's what we're saying. We don't want a negative variable. So what you're actually seeing when you see a negative variable, you can say a -1g over 8 is less than 2. And what is a -1g? You can also say it's -1/8 again. -1/8 g is less than 2. You can see something like that. Now we have our negative, and we just do what we did before. And what we did before was we divided the -1/8 on both sides. And we had g. Now we have to flip it because we're dividing. It's greater than -16. So let me go over that again to make sure you understand. I'll give you another example. Let's say I had a -c over 5 is, let's say, greater or equal to 3. Right? So again, what we're seeing here is a -1c over 5 is greater or equal to 3. So what's the next step? Bring this up a little. So what you have then is a -1/5 c is greater or equal to 3. And you divide the 1/5 on both sides. So try that. Divide the 1/5 on both sides and see what regular c is. Okay, so we'll erase this part. We'll try it here. So now you're going to have, we'll bring it up here, -1/5 c is greater or equal to 3. We're going to divide the negative 1/5 on both sides. Cancels. Whatever you do to one side, you do to the other. And now we know we're going to flip the symbol. Now it's going to be less than or equal to. Right? And if you bring this over, it'll be negative 15. So that would be our answer. Okay, so let's try writing an inequality. Here it says 15 is less than, keep this in mind, less than the product of negative 9 and a number. So we know the answer to multiplication is the product. So how would we write this? Just go slowly. It says 15 is less than, there it is, 15 is less than what? It's less than negative 9 times a number. We can use a variable, x or y, whatever we want to use. There we have it. And if we want to solve something like this, divide the negative 9 on both sides. And we know if we have a negative on both sides that we divided, the answer will be flipped. So 15 over 9, negative 15/9 is greater than x. And you can leave that as an improper fraction, or you can just say negative 1 and 6/9, and you can reduce it. Say 6/9 is greater than x. So you can leave it improper or make it a mixed number depending on what I ask you on a quiz. And if I say write it in simplest terms, don't forget that you have to reduce that. So it would be negative 1 and 2/3 is less than x. Or you can make it a decimal. Bring that over. Okay, see if you can do this one. A number divided by 8 is at most negative 102. Remember, we used those terms in the last video. So a number, we don't know what the number is, so we can say x is divided by 8. The number is divided by 8. Top number. If I said 8 is divided by a number, if I said 8 is divided by a number, it would look like that. But I'm not saying 8 divided by a number, we're saying a number divided by 8 is at most. So it can't be more. If it can't be more, it could be that number or less negative 102. It could be 102, but it can't be more than negative 102. So it has to be less. So anything less than 102 would be like negative 103. Remember, in negatives, in a negative world, the bigger numbers would appear to be bigger or actually smaller. Then we can solve this again. We're actually saying 1/8 x is less than or equal to negative 102. Or you can just simply multiply up. So what would you get if you did that? Now remember, you're not dividing a negative on both sides. So you're not going to flip or reverse the symbol. Right? So this will be variable is less than or equal to, and again, negative 8/16. Okay, that's multiplying and dividing with inequalities. Great job.